Now let's look at how to determine formulas for ionic compounds when the charges don't cancel out in a 1-to-1 ratio. The two ionic names listed on this slide are aluminum sulfide and lead parentheses Roman numeral 4 oxide, which is called lead 4 oxide. Let's address aluminum sulfide first. Aluminum always has a charge of positive 3, and sulfide always has a charge of negative 2. We see that these two charges don't cancel out in a 1-to-1 ratio. Thus, we have to find the least common multiple, or lowest common denominator, of 3 and 2, which is 6. We cannot change the charge of the aluminum or the sulfide ion, but we can change the number of ions. 2 aluminum cations will form a charge of positive 6, and 3 sulfide anions will form a charge of negative 6. When there are 2 aluminum cations for 3 sulfide anions, the overall charge is 0. Thus, the formula for aluminum sulfide is capital A, lowercase l, subscript 2, capital S, subscript 3, which means there are 2 aluminum cations for every 3 sulfide anions. Plus 6 and minus 6 is an overall charge of 0. Looking at lead parentheses Roman numeral 4 oxide or lead 4 oxide, we know that the charge of the lead cation is positive 4 because that's what the Roman numeral 4 signifies. We also know that oxide has a charge of negative 2. We need to find the least common multiple, or LCM, or least common denominator, for 2 and 4, which is 4. The positive 4 charge of the lead 4 cation will be canceled out by the negative 4 charge of 2 oxide anions. Each lead 4 cation needs 2 oxide anions to cancel it out. Thus the formula for lead 4 oxide is capital P, lowercase b, capital O, lowercase 2, which means for every lead 4 cation there are 2 oxide anions for an overall charge of 0.